Alright, welcome back to my channel. We are going to do another part today. Parts, it's all about the parts. Now you go to your create new and you make a part. Also, I noticed that I cropped the top in the first two videos, so I apologize. I will not record them again, but I fixed my cropping and now we can continue. So in the last part I drew a circular shaft, which I did with extrude base, but today we are going to show how to do it with a revolve. So let's take the front plane. I want it to be here. You hit the revolve. Now I usually drop down a center line in the middle, and later on it will help me with the revolve. And now I am drawing my whatever it is I'm drawing. I draw half of it because it's going to do a 360 revolution around it, no scope and so on. So as you know, relation to the origin, let's tell it that it's horizontal. I want it to be, no, I don't want it to be anything yet. I'm going to use lines, and I'm going to do, I'm going to do this. All right, and this is going back, and this will be merged. I'm going to tell it it's 100 in total. All right, now I have blue sketch elements and I need to tell them what they are. This should also be closed. So let's say this is 85. No, 85 is too long. Let's say it's 70. This should be like 3 millimeters, and this is derived. Yeah, all right, cool. Now since this is a revolved part, it has diameters, and when you want to create a diameter, you can do either half, or when you click, like let's say I want to decide on this diameter, and this is now the radius, and if you go over the center line, it becomes a diameter. Amazing. Actually, let me check something. M24 screw. So let's follow this. And 24 in length. Well, I actually decided length. It is 70, which exists. D is going to be 15. No, bad. So I don't want this. It's going to be 15. Because it's all derived. It's like I overdefined it and you don't do that. If let's say it's 0.5 and this thing, what was the diameter? C and 24. Let's say it was 31. It's a range. I'm just taking it so it will be round and nice. E for 36. So, and we are fully defined and we can revolve. It's currently open and it closed it. So we almost have a screw. We need, like, until now I only did one feature parts, but you're not going to do a lot of that. So let's take extruded cut, click here, Control 8 to normal, and let's take this thing. Now you can either do that or this, but we're going to define it freely, and we're going to say E we define as 36, which is between these two, And now we just need to say that this is vertical, for example. And you can already see that we made a boo-boo. Flip side to cut. Yes. And it's not gonna cut anything, so let's wait with that a bit. And exit. Now you go back here, you need to define here 36. I already defined it as the cut thing, so let's take 40. Let's take 42. It's anyway going to get cut by the other one. So you click your sketch, you go cut, flip side to cut, because you see this little arrow. This cuts on the inside, this cuts on the outside. You go here, you say okay. This is not the type of screw I wanted. This screw sort of exists, but instead of blind, you go up to next surface, or you can say to surface and you choose this one, and then you have a bolt. Cool. Now and a lot of people will tell you either have to do the spirally thingy with the, what is it called? You can define a sketch that goes up in a spiral. It's called a spiral. But you can actually do a cosmetic thread if you so want. From here up to next. Then you have this little thing there. And let's see if we can make it a D. Okay. E thread. M20. Funny. No M24. Funny. Conduit. No, we don't want the conduit. This. Here you need to define a circular edge. And say through. Anyway, this, as you can see, it's very fumbly. But the thing is, when you go on YouTube and you look for Solidworks screw, you're gonna see all these beautiful things, really amazing, rendered and crazy with a spiral and all that things. But you don't need it. No one cares. As a mechanical engineer, no one cares. It doesn't matter. As far as I'm concerned, this is the thing. This is done. Oh yeah, we can go here and do a, give it a chamfer. Here, 2 millimeters. Oh, so beautiful. Oh my god, look at this. Look at this beautifulness. Oh my god. So beautiful. Oh wow. Look at how beautiful it is. It doesn't matter. This takes so much, like, think this is running smoothly. This is fine. No problem. But when you have this times, I don't know, a normal machine you're gonna work with is gonna have at least 500 of these. So it has to calculate this chamfer, it has to calculate this fillet 500 times. So for all intents and purposes, for me, this is fine. I understand there's an M24 screw there. That's all I need. I don't care anymore. All of this like stuff, like, yeah, it's super well made, super like qualitative and amazing, and like, yeah, but it doesn't help my design. This is just like, if you want to You want to practice a splines or what is it called? Helix spiral. Sure, okay, cool. Be my guest. Be my guest. Be my guest. But it doesn't help your design of the machine. So yeah. But this is how you make a base feature for your part. Another thing you should avoid. This at all costs. And a lot of people will do, instead of what I did, you might be tempted to go and do this to give the chamfer that I put later as a feature. You don't want to do that because of one reason: how robust your design is. Because when you want to change something with that, you can also do what is it? A sketch fillet. I see this a lot. This changes it changes your sketch and makes it a lot harder to change. It makes it a lot harder to sort of work with. I would not, if I have to, I absolutely must, I would rather have a feature that does this or the fillet rather than do it in the sketch, because in the sketch it can become a nightmare. Like, you have to change something, if you have to modify, and when you need to modify, this becomes hell. It becomes a lot of work, and you don't want to add extra work. You want to design your design so that it's easy to redesign. I just made that up. Yeah, this shouldn't be, they want it to be closed. Okay. Anyway, yeah, circular parts, super useful. Use them, do them, and I will see you in the next one some other time. Don't worry, we will get to mates and machines and doing huge crazy assemblies, but we first need to learn how to crawl before we walk, before we run. All right, cool. See you later.